Hello, my name is Rachel Kuzmich, and I am very excited to participate in this year's Ontario Ecology, Ethology, and Evolution Colloquium. Since we are doing this all asynchronously and virtually, I wanted to take a quick moment to introduce myself. I am a PhD candidate in the Department of Geography and Planning at Queen's University. My research is interested in examining bird habitat with remote sensing data. And I have two study sites, the Queen's University Biological Station, just north of Kingston, Ontario, as well as the Monks Woods National Nature Reserve and the surrounding Cambridgeshire Woods in the United Kingdom. And that is the study site that I will be discussing today. Now, the Cambridgeshire area is primarily an agricultural landscape. The largest woodland in that context is the Monks Wood National Nature Reserve, which is identified with the yellow pin. And there are a number of small woodlands in this agricultural context as well. The ones that I am going to be discussing in this study are Gamsey, Ladies, Raveley, Riddy, Wilderness 1, and Wilderness 2. Now, these are small woods, the smallest being Gamsey at 4.9 hectares, and the largest being Riddy at 9.4 hectares. You'll note that there are two pins just to the south of Monks Wood. These are the two wilderness areas which are adjacent to this larger woodlot, and the others are scattered more to the northeast. Now, this is an area that is actively undergoing forest succession, and forest succession refers to a directional change in tree species composition and three-dimensional structure over time. And within this three-dimensional context, there are, of course, a number of species. And the two that I am interested in are Chiffchaff and Willow warbler. Now, these two species are considered habitat specialists, with willow warbler preferring the early successional habitats, and Chiffchaff habitat is described as more mature woodlands. Now, I mentioned that I'm using remote sensing data, and in particular for this study, I am working with airborne laser scanning data. Now, you might have heard this called LiDAR, light detection and ranging. And what this is it's an active remote sensing data type where a plane, in this instance, flew over the target area, and it emits a light pulse, measures the time it takes for that pulse to return, and then converts that measure of time to a measure of distance. And the output is a dense, spatially explicit, three-dimensional point cloud. ALS has been used to look at forest succession in previous studies. This is one by one of my former peers, Karen Van Ewijk, 2011, who was looking at 4 stages: stand initiation, stem exclusion, understory reinitiation, and old growth stage. And these 4 forest succession stages were described by Oliver and Larson in 1996. And what we can see here is there is a change in the distribution of points over time that you can see in the three-dimensional LiDAR point cloud. And you can see the distribution of those points on the right-hand side of those point clouds, and an image of what those areas look like in the photograph on the left-hand side. Airborne laser scanning has also been used to look at birds. The figure on the right-hand side from Millen et al. 2018 is actually from one of the same woodlands that I'll be using in this study, Ladies Wood. And the image on the right is from MacArthur 1962. Now, this study was not using ALS at the time, but it shows a really nice kind of continuity with those early studies. So the figure on the left has 3 axes, which represent 3 layers in the vertical profile. So 0 to 2 feet is the herb layer, 2 to 15 is the bush layer, and 15 feet and higher is the tree layer. And each point represents the proportion of foliage in those 3 layers for a dozen different bird species. Now, as MacArthur put it in this study, this gives a crude picture of the profile. And with ALS, we can get a little more specific. Now, the goals of my study are first to identify optimal ALS-derived structural variables that describe the habitat for Chiffchaff and Willow warbler, and then to characterize that habitat, and finally to determine its availability across space and over time. I am using 4 ALS data acquisitions from 2001, 2005, 2012, and 2015. And I'm using bird data that was captured that same year, as well as the 2 subsequent years. And I'm using all of this data to create a global model for Chiffchaff and for Willow warbler. Now, the ALS variables that I am looking at are descriptive statistics, so things like mean, standard deviation, skewness, kurtosis, for the entire vertical profile, so from the ground to the top of the canopy, and for 3 layers or strata within that profile. So the first strata below 2 meters, the second strata is 2 to 8 meters, and the third strata is above 8 meters. And I'm also looking at foliage height diversity, as well as canopy openness, so looking at gaps. And we can see these 3 strata are represented in the ALS point cloud as well. So the lower strata, strata 1, the middle strata, strata 2, and the higher strata, strata 3. And these 2 images are actually where, on the left-hand side, Willow warbler occurs, and on the right-hand side, where Chiffchaff was present. So even just looking at these 2 point clouds, anecdotally, we can see that they look different. I am using random forest to do my modeling. I know I have a lot of forests in here. This forest is a collection of decision trees. As a random forest tree is established, data points are assigned to a branch at each node with increasing homogeneity until no further classification is possible. And the large number of decision trees in the collection makes this method insensitive to overfitting and increases the variable importance stability. Each tree is built with training samples through replacement, so bagging, and the output is that estimate of variable importance, an accuracy or out-of-bag error, and a Gini coefficient. Now, the results of my random forest model for Chiffchaff and for Willow warbler are pretty good. The out-of-bag error estimate for Chiffchaff is around 29%, and Willow warbler is around 10%. And looking a little more specifically at the error associated with presence and absence, we can see that for Chiffchaff, the error is higher for absence, and for Willow warbler, the error is slightly higher for presence. And what this tells us is that the Willow warbler overall is more specific in its habitat selection, and it's particularly specific in the habitat that it doesn't like or doesn't use. In addition to these kind of internal measures of accuracy, I also calculated the area under the curve, AUC, just to give a second accuracy assessment. And what we found here is aligned with what we found from the model itself. So both models performed quite good, with Willow warbler being a little more accurate. So the AUC value for Chiffchaff is about 0.79, and Willow warbler is about 0.95. Now, looking at the variable importance, I have the graph for Chiffchaff on the left and Willow warbler on the right, and I know that there's a lot of variables at the bottom, so I really want to draw your attention to the top 3. So for Chiffchaff, we can see that it is associated with the maximum elevation of the entire vertical profile, and then 2 variables from the third strata, maximum and standard deviation. For Willow warbler, again, we see that maximum elevation of the entire vertical profile shows up, and here it's 2 variables associated with the lower strata, the first strata, standard deviation and kurtosis. So the message is pretty simple. Chiffchaff likes the higher part of the canopy, and Willow warbler likes the shorter part. And we characterize the habitat using these top variables. In this instance, using the top variables for Chiffchaff, we can see some differences between the habitat preference. So Chiffchaff is on the left in blue, and Willow warbler is on the right in orange in both of these graphs, and we can see that there is a fairly good separation with a little bit of overlap. Chiffchaff likes higher and more diverse in the third strata. When we look at the variables that the willow warbler prefers, we actually don't see that much of a difference between the two species for kurtosis and standard deviation in the first strata. So what this suggests is that where the willow warbler prefers, there may be chiffchaff, but where the chiffchaff prefers, there won't be willow warbler. And when we look at the maximum height, which was important for both of them, we see the greatest separation. So again, chiffchaff preferring the higher side of things and willow warbler preferring the shorter side of things. I mentioned that I'm looking at 6 different woodlands, and we can see that the availability of habitat differs across these woodlands. Some of them there's a pretty clear kind of half and half separation. Others you see that there is more of an edge center separation between habitat. And if we look over time, again, I have 4 ALS acquisitions, 2000, 2005, 2012, and 2015. We can see that the availability is changing over time. So in this instance, in the first data capture, willow warbler had suitable habitat kind of throughout the center of this woodlot. And by 2015, that had greatly diminished. And we can see this in the canopy height models as well. The lighter colors here are taller and the darker colors are lower. And in particular, when we look at the difference between 2000 and 2015, we can see that this woodland has been growing. So in sum, airborne laser scanning can be used to characterize habitat for chiffchaff and willow warbler. Some variables are more important than others, and for willow warbler, that was variables in the lower portion of the canopy in the first strata standard deviation kurtosis. For chiffchaff, that was higher up in the canopy, the third strata maximum standard deviation. And for both of these species, maximum height was important. Willow warbler is more specific than chiffchaff, and the availability of habitat differs across basin over time. I want to acknowledge and thank everyone who assisted me from providing feedback to helping me with data. And I want to thank you for listening to my talk today. If you do have any questions or any comments, please do feel free to follow up with me by email. Thanks so much.